Okay, what if I told you that a common waste product, something the paper industry has been literally throwing away for a century, might just hold the key to our green energy future? Yeah, let's get into it. So, we all want a cleaner planet, right? We're all in on electric cars, solar panels, the whole deal. But here's the thing. Our current path to going green has a surprisingly dirty secret, and it's buried deep underground. And that forces us to ask a really uncomfortable question. What if this green revolution that we're all counting on is actually being built on a foundation of, well, environmental destruction? It's this huge contradiction right at the heart of everything we're trying to do. And this really just lays it all out. On one side, you have the promise, right? The clean, silent EVs and renewable energy. But on the other side, you have the reality. The supply chain for our current batteries often means huge amounts of water usage, landscapes that are scarred forever, and really dangerous work for people. This is the dark irony we absolutely have to solve. But what if the solution isn't about digging bigger and deeper holes in the ground? What if the answer has been right in front of our faces this whole time, not buried underground, but hiding inside our forests? So let's meet our unlikely hero, lignin. Now, here is the absolute best way to think about it. If cellulose is like the steel rebar that gives a tree its structure, lignin is the concrete that holds the whole thing together and makes it rigid. It is the second most common organic polymer on the entire planet, and yet, for over 100 years, we've basically just ignored it. And just how much of it have we been ignoring? Get this. The global paper industry produces up to 70 million tons of lignin every single year. That is a truly staggering amount of raw material that we have just been treating like trash. For decades, the stuff was just a nuisance. It was this thick, dark waste they called black liquor, and paper mills would just burn it, for a little bit of heat. It was the lowest value, most basic use you could imagine for such an amazing material. But that is all starting to change. So the big question is, how on earth do you turn this humble byproduct from a forest, this wood paste, into a critical piece of a high-tech battery? Well, the answer is in some pretty cool science. It all comes down to a process called pyrolysis, which sounds complicated, but it's basically a three-step journey. First, you pull the lignin out while making paper. Second, you refine it down into this really fine powder. And third, and this is the magic step, you cook that powder at over 1,000 degrees Celsius without any oxygen. This crazy heat treatment rearranges all its molecules and turns it into something new called hard carbon. And here's the kicker. This hard carbon isn't just a replacement for what we use now. No way. In many ways, it's a massive upgrade. It creates a fundamentally better battery anode, which is a super important part of how a battery actually works. To really get why, you have to look at the old way. Traditional batteries use graphite, and its molecular structure is incredibly neat and tidy, like a perfect stack of papers. The little energy-storing ions have to carefully slide in and out between all those layers. But the lignin way, it's totally different. The hard carbon it creates has a structure that's messy, it's porous, it's jumbled, kind of like a house of cards, as you can see. And while messy might sound bad, for a battery, that chaos is actually its superpower. I mean, this showdown table really says it all. That messy house of cards structure, it means you get way faster charging because the ions can just zip in and out of all those pores super easily. It works much better when it's cold out, and maybe most importantly, where it comes from. It's a renewable byproduct from a forest, not from a mine. The environmental cost just plummets. It's a huge win, pretty much across the board. Okay, so let's zoom out. What does this really mean for the whole planet? It means we can finally start building a truly circular battery, one where the supply chain is just as green as the tech it's powering. Just think about this for a second. We don't need any new land for this. The trees are already being harvested for paper. This means countries that have forests can start making their own battery materials, which completely slashes the carbon footprint from shipping minerals halfway around the globe. It's a massive step towards a real closed-loop economy. And this has huge geopolitical implications. As this chart shows, right now, the world is about 90% dependent on China for the graphite that goes into our batteries. Lignin offers a path to energy independence. For nations in Europe, North America, you name it, they can turn their own sustainable forests into a source of energy security. Now, this technology is incredibly promising, but let's be real, it's not a silver bullet just yet. We need to take a look at what's next on the road to this forest-powered future. There are basically two main hurdles to clear. First, researchers are pushing to pack just as much energy into this lignin carbon as the absolute best synthetic graphite can hold. Second, since lignin from a pine tree is a little different from a birch tree, they need to create a standard process so that every single battery performs exactly the same every time. But this is where it gets truly exciting. The ultimate endgame here might not even involve lithium. Lignin's unique house of cards structure works perfectly with sodium, which is way cheaper and way more abundant than lithium. This means that the combo of sodium and lignin could literally produce the cheapest, greenest battery in human history. So, we end on this one last thought. It's an idea that just turns our whole concept of resources completely on its head. Is it really possible that the answer to one of the biggest crises of our time has been hiding in plain sight, in a pile of industrial waste we've been burning for over 100 years? It's starting to look like the answer might just be yes.